Welcome in. We're live. Hello, everybody.
Hello.
All right, we're going to jump right in. We got a lot to show you all today. We're going to make it quick. We got a lot of stuff to show off over the next couple of months, and this is just the start. What do we got, Lucas?
Yeah, let's get going. We announced private nodes with vCluster version 0.27 this week. Very, very big announcement. Really, really excited to show you some of the details here. And we have Fabian on the call as well, my CTO and co-founder. We'll dive into the technical details in just a minute. But let's get a quick overview of what vCluster has been, mentally so far in everybody's heads for the past couple of years, and how we're changing that right now, how it's expanding, and what else will be possible with vCluster. So I think everybody's familiar with, what we call this first tenancy model for vCluster. It's really shared nodes. That's a lot of the reason why people use vCluster today, to drive up utilization, to make your Kubernetes more efficient. And it essentially means you take a cluster with a couple of nodes, then you spin up a vCluster inside that cluster, runs inside a namespace. It's just a Helm install. You can deploy it via Arc or CD, Flux, right? Like any favorite infrastructure as code or GitOps tool. And then that vCluster can now, sync pods to the underlying cluster. So you're actually talking to the vCluster's API server, but the pods get created in the underlying cluster, and the underlying cluster has nodes, the scheduler, right? And that means you can have multiple vClusters that share a particular node, something that generally isn't possible in Kubernetes. In Kubernetes, you have one node belongs to one cluster, right? It's a very static assignment typically. That's the traditional vCluster. Earlier this year, we announced a product called vNode, which now wraps pods from the same vCluster into what we call a virtual node. That means, pods from vCluster A and pods from vCluster B, they end up maybe on the same node, but they'll be in separate virtual nodes. These virtual nodes are kind of like secure sandboxes for isolating things, on the node level. vCluster gives you that, Kubernetes level isolation. Every tenant can have their own CRDs, namespaces, RBAC, network policies, you name it. But, if you actually want to prevent, things like container breakouts and noisy neighbor issues on the node, vNode is a really great addition to using vCluster, especially if you use this shared node model. CNI and CSI is still going to be shared in this model in any case. The second model you have for tenancy with vCluster is dedicated nodes. Dedicated nodes works pretty similar to that first model, but in this case, we're labeling the nodes. We're saying, okay, this is a node for tenant A, and these two nodes are for tenant B. And now I'm saying, okay, vCluster A is for tenant A, so it can only schedule pods on this node here, versus vCluster B should go with their pods on that set of nodes. That's pretty nice because, obviously changing labels is quite easy. It's pretty easy to rebalance nodes from tenant to tenant with this approach. And it gives you that isolation on the node level, so you don't even need tools like vNode. No node is actually shared. But it's still a shared cluster, so CNI, CSI is still shared, and you need a bunch of policies in order to keep things separate, right? Network policies, etc. What we're introducing today is a really exciting new model in how to run vCluster. And we call it private nodes. What you can do with private nodes is, instead of having a shared cluster, so there's still a cluster that runs these control planes, but instead of using the nodes of that underlying cluster to run pods of that vCluster, you actually give the vCluster, separate nodes that are dedicated only to that vCluster. That's why we call them private nodes. These nodes are not usable by any other vCluster or by any other cluster for that matter. We're joining this particular node directly into this vCluster, and we're taking these two nodes and we're joining them into this vCluster. Think of it like kubeadm join into this control plane. So effectively, we're forming two completely separate assumed clusters here, right? That means CNI, CSI, everything is completely separate. And, you get the highest degree of isolation, for your different tenants. That's really, the novelty of what we're introducing here. Fabian, Mike, anything to add at this point?
No, I think that sounds good.
I'll tell you, when I was messing with it, it changed the way I was thinking about things, because I'm like, oh, I've got all this stuff on my host cluster, I'm just going to share it. But it feels more like I'm making my own EKS and I'm building this whole control plane and connecting things in. So it's like, I create a load balancer. I was like, oh, wait a minute, I don't have a load balancer on here because I'm not using the same shared stuff. I've got my whole new cluster. So it's an interesting way to think about things differently.
Yeah, definitely. I think we started with multi-tenancy as kind of like the core of what vCluster is, right? Sharing a cluster, splitting it up, having multiple tenants in the same cluster, and trying to see how can we give them the feeling like they have a fully blown separate cluster without actually creating one. Now we're kind of starting to create separate clusters, right? So it's really more of a single tenant approach. What is still in some ways multi-tenant is that cluster that runs your control planes here, right? So you still have one cluster that runs, several control planes for your different tenants, but the nodes are completely separate. Networking, storage, everything is completely separate for each one of these separate clusters. When you look at, traditional clusters, obviously, they require a lot of, VMs traditionally to run the control plane, right? So typically you have like 3 etcd nodes, then you have at least 2 times replicas running for the control plane. Maybe there's a way to overlap them and saying, okay, I'm running 3 VMs in total, and I run on all 3 I run an etcd replica and a control plane replica for Kubernetes here. But it still requires a lot of machines to be spun up, whether it's bare metal machines or virtual machines. You have a lot of that machine maintenance going on, and the clusters, they're pretty rigid when you spin them up in this way. vCluster kind of turns that around, and we essentially require one traditional cluster to be spun up, and this can be an EKS cluster or an OpenShift cluster in your private cloud, or whatever you're using as your base Kubernetes distro, RKE2 from Rancher, etc. And then you start spinning up these vCluster control planes on top. And the beauty of that is they're now very dynamic, right? These control planes, in the easiest case, are just a single part of a single container. That's all it takes to spin up a vCluster. And if you wanted an HA mode, you set the replica number to 3, right, of that stateful set. And boom, you got an HA etcd, you got an HA API server controller manager, etc. Like all the components of a Kubernetes cluster. And that's really straightforward to create clusters with this approach. And just as before, vCluster is always a certified Kubernetes distro. So we're validating against all of the CNCF's compliance rules that make up a certified Kubernetes distro, and making sure with every release we're passing them. The beauty of running your control planes not on VMs, but running them inside Kubernetes, is that you can manage your Kubernetes clusters just like you would manage any other application. When you think of it, right, the way you manage your applications today is probably via something like Argo CD or Flux or any other GitOps tooling, right? You can now manage your Kubernetes clusters the same way as if they were regular applications. That comes with all the benefits of running inside Kubernetes and running inside containers. That means you could auto scale replicas depending on load, right? There's a lot of things. You get auto healing, you could automatically, you can kill one of your replicas and have it rescheduled if one of your nodes dies, for example, right? There's so many benefits of running things directly in Kubernetes rather than running them on static VMs. And you can see here on the list on the left-hand side, you can spin us up with more than just things like Argo CD and Flux. You can spin up vClusters with Cluster API, with Rancher integration. We obviously have our own CRDs, or you can just use our Helm chart, right, which is at the core of everything, or you can run Helm template and kubectl apply it, right? Pretty straightforward. We obviously also have vCluster CLI. We have a nice UI as part of vCluster platform. But no matter how you're doing it, generally you specify a declarative file called vCluster YAML, which specifies, for example, which Kubernetes version do I want to run. And then you apply it to your cluster, which essentially is a Helm install. And then that spins up a vCluster control plane. Ideally, if you also have vCluster platform running, all of these control planes are registering with vCluster platform. So you have a nice overview of all the clusters that you're running, who has access to them, what versions do they run, which one needs to be upgraded, where might there be an issue that needs to be debugged. You can stream the logs, right? There's lots of things you can do, but totally optional. You can obviously spin up virtual clusters outside of the vCluster platform as well. Now, what about the nodes, right? This stream is all about private nodes, our new feature. Traditionally, assigning nodes, especially in the private cloud, has had quite some issues because, if you're assigning nodes, it's a very, very, static, rigid assignment. So if I create a set of nodes, I assign it to, a cluster, and I create another set of nodes and I assign it to a cluster. What can happen quite easily is that, one of your clusters is highly underutilized, another one is highly utilized. And, maybe this team here or this business unit could do a lot more. Let's say, this is like, NVIDIA H100 GPUs, for example. And, there's not an option for you to just buy 1,000 more of those because, they're very expensive. It may take months for them to get delivered, etc. So really what would be much nicer is to say, hey, this team needs more. This team is underutilizing their current estate, so let's just move a node from here to there. Today, that is not quite as easy as an operation, especially in the private cloud. Obviously, if running things like EKS, this is a little bit easier, but in the private cloud, this is really difficult. With vCluster and private nodes, we made it quite straightforward to move nodes from one cluster to another by essentially creating a single command that joins a node into a cluster. The only thing you need to do with private nodes to join any node into a vCluster control plane is you connect to the context of that vCluster. We have a really handy command here, vCluster connect, in order to do so. Then you run the command vCluster token create. It's similar like kubeadm tokens, right? And it spits out a curl command, which essentially provides a token. If you run this, curl and then, pipe it to sh, you join the node into the control plane. So I can run this for those two nodes to vCluster A and those two nodes to vCluster B. And if I want to move a node, I can really easily, restart the node, wipe my node, and then run the command for a different vCluster. It's as easy as running a single command in order to join a node into a different vCluster. And last but not least, upgrades are all automated. So that means when I want to upgrade my Kubernetes version, I update the vCluster YAML file, I set a new version here, then I apply it to my Kubernetes cluster that hosts my control planes. What will happen is, the control plane will upgrade, but also each node will upgrade. We run a privilege pod on each node that runs through all of these steps over here. And you can also specify, do I want to upgrade 5 nodes at once or 1 node at a time, right? And we'll obviously stop if there are any issues. So you can take a look. But generally, this is a very, very resilient upgrade process, and it's fully automated. Additionally, we have, obviously tools like vCluster Snapshot that people are familiar with from prior releases. I think this is maybe like 9 months old or almost a year old at this point when we announced vCluster Snapshots. And, vCluster Snapshots is a really, really quick way to snapshot the entire state of your vCluster, get the entire state of etcd. It's a great way to back up your cluster right before you perform such an upgrade. So obviously you get all the benefits of regular vCluster, embedded etcd. You get the etcd, snapshots with vCluster Snapshots. You get auto healing of your etcd. All of the goodness that we baked into vCluster is also possible with private nodes. And I think that's the last slide I have on this introductory part. Hopefully this gave everybody a good overview. There's also in the, I think, blog post out there and a release announcement. But yeah, Mike, why don't we jump into a demo and go a little deeper from here?
All right, cool. Yeah, let me jump into this demo. Should work. I've tried it multiple times. Here we go. We're gonna give it a go. I'll give you a little background on like actually what I've set up to. So let me go and share my screen. Let's do this. I think everyone can see that. And then Fabian may comment too on some of this stuff too, because I'm going to be over here doing some stuff. All right, yeah. Stop me if you have questions. If anyone has questions in the chat or something like that, and you want to know what we're doing or what's going on, let me know. Hopefully everyone can see this over here. Let's go ahead and get started. So I've got this new vCluster.yaml that is going to be associated with this private node vCluster. So some of the changes are, I've got private nodes enabled. I need to have this enabled, and I cannot change this later, right, Fabian? Like this is something I have to have enabled when I start and create this. I can't upgrade from a different one and do this. This is gonna be like a brand new node.
Yeah, exactly. So right now it's an either or situation. You cannot mix or switch between the modes. So you either do like private nodes or you do shared nodes, but that might change in future. So yeah, that would be obviously a cool enhancement. But for now, you need to decide what you want.
All right, I'm gonna go ahead and create this. So right now I have a K8s cluster that I'm running this all on. You can think of that as my control node cluster. And then I've got 2 VMs that I've created with Terraform on Proxmox that I'm actually going to connect in. So I just created these before we got started. And I've done like, apt-get upgrade and update and all that stuff. So that's the state we're in. So I'm creating a brand new virtual cluster on my 3-node K3s cluster. I'm going to connect in 2 virtual machines that I've created. Now, these are all on-site and on-prem, but you could connect in stuff from the cloud if you wanted to, Fabian. Like I could have like a Kubernetes cluster that has a node that's on, Google, or a node on AWS. Like I'm not joining in EKS or GKE. I'm joining in like bare metal. I'm joining in virtual machines instead, right?
Yeah, exactly.
All right, so now I've created this virtual cluster. I'm connected. If I get my context, I can see that I'm connected to this. If I get nodes, I've got no nodes. So like I can't do anything here. I can't really actually run anything. But this is running on the default cluster. So next what I'm going to do is I'm going to use the command that Lukas showed, and I'm going to generate my token. Now this token
Maybe you can also really quickly, sorry to interrupt, but just show the pods, because we will see these pods are now, so just do like so
they're pending. Okay.
Yeah, they're all like pending because there's no nodes, right? So this is like obviously very different from shared nodes. So vCluster here is now waiting for a node to join. And now it's like, all right.
Let's do this. K8s nodes will watch, and then I am. Oh, here we go. So we're going to join in VM4, and then after that joins in, I'm going to exit and I'm going to join in VM5. So we're going to get 2 nodes on this. I mean, you want 3, but we're going to have 2 nodes for this, just so we can kind of show the upgrade, the drain, and all that stuff too while it's going live. So this node is going to join in as soon as this one's done. Like I said, go ahead.
What's interesting as well is that kind of everything is installed that's required, right? So it's not just like a simple join and we expect everything to be there. No, we install containerd, we install kubelet, kubeadm, and those binaries are actually part of the control plane and downloaded from the control plane. So this also works very nicely in air-gapped scenarios where you don't have access to the internet. And everything is just essentially on the control plane. So we see that the binaries are really downloaded from this private IP here. And then, missing packages are installed if needed. And then, the node is joined as an actual Kubernetes node into the cluster.
And if you can highlight the curl command again at the top, I think it's almost out of your screen there. Yeah, it's at the very, very top line. Now it's gone. Sorry, on the left-hand side.
On the left side, yeah.
On the side? Oh, here,
the join command over there, right? The curl command. You'll see that we're curling from the control plane, right? So that IP address here is the IP address of our vCluster control plane, which is really nice, as Fabian said, because the control plane owns these binaries that you need in order to launch a Kubernetes node. And that makes it really straightforward in air-gapped scenarios, right? You really just need to have the control plane up, and then all the nodes need to do is have connectivity to the control plane, which obviously they need anyway, right? But they don't need any outside connection. They don't need to download anything from GitHub or Kubernetes releases or something like that, right? It just gets retrieved from the vCluster control plane, which is pretty neat.
Yeah, and everything else on the node itself is also pure vanilla, right? So we don't rewrite any paths. It's vanilla containerd without any recompiling or kind of changes. So you have like on the node itself a really pure Kubernetes installation, which makes using things like GPU operator, for example, or any other kind of like CNIs or Istio really easy because those usually need certain paths on the node to be present. But with this, it's all vanilla, all default. So everything runs out of the box basically.
And you're highlighting the load balancer here. You're running MetalLB, or what do you do?
Yeah, so I assume some stuff, right? Like there's assumed knowledge here. I'm running K3s with MetalLB, so this is like all on-prem. It's home lab, but it's like comparable to doing like a bare metal on-prem type deal. It's like I'm running MetalLB now. If you're running this somewhere like AWS, or like the load balancer might be like a host name or something different. But this is my endpoint. This is where that came from. I'm running MetalLB, and it's all local IP addresses. All right, so everything got
cool setup. You should open your closet and show us the rack in there.
Well, I recently opened it up so like Siam can mess around with it too, right? Because I've got GPUs, I've got a couple of things running, so we can kind of mess around with it. Because it's hard to get GPUs. It's hard to get GPUs, get it set up and working and everything. So I've got my little home cloud that I'm kind of sharing out so that we can kind of like write some cool stuff. But
awesome.
All right, cool. So our nodes are joined. Let me go ahead and exit out of here. what we're going to do first is we're going to deploy something super simple, right? Just so we can kind of watch a connection happen as we do an upgrade. Because this is cool, but like, what if I want to upgrade my version from 1.33.1 to 1.33.2? And I want to make sure that all my nodes upgrade too at the same time without actually doing anything. I can do that, but let's go ahead and create the application. So I'm going to create a namespace. Let me make sure I'm in the right spot. And then let's get pods, all namespaces to make sure everything came up. Sweet. Everything's running now. So like Fabian said, everything was waiting for somewhere to run. It has found somewhere to run, and now it's running. So you can see all the pods that are currently running. Let's go ahead and create a namespace demo. I'm going to deploy Nginx. So I copy paste, so it's a little bit faster than me typing it out, and you can hear my click clacks on my.
Yeah, you're pretty fast typing though. I was impressed.
I was like, I can do like 130, 140, but there's so many different keyboards I use in my house now. I mess up so much more often than when I only had one computer to mess with. Like I've got way too many types of keyboards. All right, so I've created this. I've deployed it. I'm now using node port instead of a load balancer because, like I said, this vCluster doesn't share everything that's on the host cluster. I need to create my own things because I've got my new areas that I'm running things. Like I'm running these on new nodes that don't know about Metal LB or anything like that. Like there's some stuff you can sync, but with this, there's a lot of things that it changes the way it works to where you're not syncing everything like in the same way. We'll have more videos and stuff about that coming out soon. Simon and I are going to make some things to kind of show more demos and give you more ideas on what you can do. So let's go ahead and get the node port so I can curl it. All right, so our node port is right here. We're going to copy this. I'm going to put it into my command. And then what I'm going to do is I'm going to run a curl and show uninterrupted connections. All right, so what I'm doing is I'm just curling the Nginx endpoint on the node port. I'm just grepping for dates so that I can kind of show like time. And then I'm just having it go every second so that I can show that it's not interrupted and there's no issues. So what's a cool thing I can actually do now? If I go in and I edit this vcluster.yaml and I change this version to .2 because I want to update everything or make another change, I can edit that. And then what I'm going to do is I'm going to go in and I'm going to upgrade it. So I can do an in-place upgrade. So I'm going to vCluster create upgrade the private node demo, which is the name of the virtual cluster. And then I'm going to use that same vCluster YAML. And the difference is going to be just that version of Kubernetes. So I'll run this. And then on this other right side, all right, so yeah, I'm gonna switch back to default so that I'm now going back to the host cluster so I can connect into the vCluster and do this thing because the vCluster is running on the host cluster. It's gonna be a little bit confusing, I think, for everybody that's used to vCluster to get used to the new way of thinking, but we'll try to create some stuff that makes it a little bit easier to understand what's going on. So on the left side, I'm doing a curl on something that's running in this virtual cluster. Right now, I'm upgrading the control plane on the right-hand side. After I've upgraded the control plane, what I'm gonna do is I'm gonna go ahead and get nodes and show that the nodes are updating too. So as soon as this comes back up and connects to the vCluster, I'll do a kubectl get nodes and watch, and then we'll watch as the nodes are, taken out of rotation until they're updated and then put back in. But it'll drain and then here we go. All right, so now I'm back in the vCluster context. I'm trying to be fast because like this is all gonna happen like pretty quickly as it comes up. It might take a few seconds for it to be like, okay, now I need to trigger off this update. But what's gonna happen now is on the right side, we're gonna automate. Now you can, Fabian, you can do this automatically or you can do this manually if you want to, right? Like you can set up to where you don't automatically update if you don't want to.
Exactly. So yeah, the default is that essentially vCluster, after the control plane was updated, waits, I think 1 to 2 minutes, and then essentially updates the Kubernetes version. And that is essentially done automatically by a small pod that we launch on each node that essentially downloads again these new binaries, right? So you remember container D, kubelet, and so on, and exchanges these in place. So there is no downtime for any workloads. And so it coordinates the node, replaces the binaries, basically restarts kubelet. And then essentially, so here we see it, like this is essentially coordinating it. And now you see it upgraded, right, from 133.1 to 133.2. And that is like fully automated. You don't have to do anything. And essentially that is also possible with a manual command, right? So I think there's vCluster node upgrade. If you don't, for whatever reason, want the automatic way, right? Or you even want to kind of like try out this on your own, you can also do this manually. And you will see essentially vCluster will do this one node at a time, right? To prevent kind of like if something should go wrong, it would stop and basically say like, hey, there is some issue. And now
we upgraded.
We're upgraded already. Perfect.
And we're just showing that like the connectivity. So if I had HA or something like that, right? Instead of, this is just a single instance of this running. But if I had an HA configuration for this, I could also interact with the endpoint, the API endpoint, and get like pods and stuff like that too, and not see anything go down, or still be able to interact with the API. Yeah.
Yeah, exactly. So if you have HA vCluster, so the control plane is HA, the control plane would never be unreachable, right? Still persistent connections to the control plane will be at least temporarily dropped because the API server needs to be replaced, right? But basically you can run kubectl get pods in an interval like every second and it will still work. Yeah, and on the left side, what's actually more important is that the workload traffic or the workloads are not restarted or anything, right? So they basically stay up and running, which is great.
Yeah, and long-running connections to Kubernetes API would really just be something like kubectl exec, right? So that may be something that gets interrupted momentarily. Does the CLI have a restart for this? Like, does Kubernetes, or it just kicks you out of the kubectl?
No, it kicks you out. The controllers though have restart mechanisms. So if you use anything like Argo CD or any cert manager, things like that, like the controller runtime definitely has retry mechanisms, right? So obviously this is kind of like a general Kubernetes thing, so that they are well prepared for those scenarios. Yeah.
See, and I don't see those nodes on my host cluster either, right? It's like this virtual cluster is running on one of these nodes, but it doesn't see these other nodes that are over here. Oh yeah, we had a question too. So how do we establish connectivity to services hosted in two different vClusters? The question, I guess, maybe is related to just vCluster in general, or maybe with private nodes. Is that gonna be like a service mesh? Like, what are you gonna use to talk to our external service or something like that? What are you gonna do?
So I guess it depends. So how, like where that other service is, right? Like, and how there could be a connection between these services. So if it's just like vCluster to vCluster, or vCluster nodes to vCluster nodes, we have a feature also planned that essentially allows you to essentially talk to other nodes there. Otherwise, since it's just regular nodes now, you can basically configure connectivity on the underlay. So you can either, like if they're in the same data center, just configure security groups, or if they are not, right, you can use tools like Istio cluster mesh and essentially use connectivity there. But as I said, we also will have something coming up that will help with this. Just not yet in this release.
Yeah. So can we talk about, Lukas, what's new that's coming, right? Because like the next question is, okay, this is cool, but like, do I really have to run Kubernetes anywhere to have a control plane? Can I do something different, right? Like,
yeah, true. There's a bunch of stuff coming. Mike, maybe we can pull up the launch series webpage here. We have really exciting announcement to make in about, I think, 3 weeks from now. And then another one about a month later. We're trying to do 3 big releases in a matter of 3 months. This is the first one. Private nodes obviously reshaping the definition of what vCluster is. Because so far, vCluster was a cluster in a cluster, right? A cluster that was running in a namespace and that was syncing pods down, and we're carving up essentially multi-tenancy in that same cluster for multiple tenants. But now, with private nodes, obviously we create completely separate clusters. And you can see here, you already see the titles on this little landing page that we put out there. The next release is going to be about auto nodes. And as Fabian mentioned, there's some really exciting stuff regarding networking in there as well. So this was a perfect question here from the audience. And then we have a third release planned, which we're calling standalone vCluster. And this vCluster standalone model is really something truly exciting. So we'll save that for the end here. You can probably guess from the names, auto modes has something to do with automatically joining nodes into vCluster. We created private nodes and we announced that right now. But what if, nodes could automatically be added to your cluster and you didn't even have to manually, we saw you earlier run the command, Mike, to join your 2 nodes into the vCluster. It's great. You have 2 private nodes now, but what if they're underutilized? What if you could actually, exchange one of these bigger nodes with a smaller node, or maybe you could bin pack some workloads, or maybe you have a lot of workloads being spawned and you need 3 additional, EC2 instances, or it would be cheaper to get you some, some Google Cloud VMs, or your private cloud would need a specific, GPU node because you're trying to run a GPU workload. All of that stuff is going to be part of the next release. It's a really exciting release, 0.28 auto nodes. So definitely subscribe to, I think there's a link at the bottom of this landing page where you can type in your email. You'll be the first to know when, vCluster auto nodes will be available for everybody.
So it's like kind of like an Airbnb, like I'm looking for the cheapest place to stay with my clusters at a given time. And maybe I'm using, spot instances to bring up like the control plane and then add nodes in, get my work done, and then just leave. Is that what you're saying? Hopefully not leave a mess, like hopefully clean up or something after my stuff, at least so I don't get charged extra because I got a bunch of stuff that I didn't clean up. Which is hard with cloud.
I mean, node management is not something anybody likes to do in Kubernetes, right? It's like figuring out what is the right size of nodes, upgrading nodes, establishing network connectivity between nodes, right? Especially if they're in different environments, right? So we're trying to, get rid of as much of that complexity as possible for admins. And in today's release, you already saw the automatic upgrading. I think Fabian mentioned that you can obviously perform that manually, but why would you? You can just have vCluster take care of it, and you declaratively change one line in your vCluster YAML to upgrade your cluster, including all the nodes. And, with auto nodes, we'll take this a step further and say, what if you didn't have to take care of nodes at all? And you just told us, hey, I want nodes from maybe, Google Cloud and AWS, and here's what I have in my private cloud. And we figure out automatically what is the right set of nodes to be joined in your vCluster. And maybe you have 3 vClusters, and we rebalance and move one node out of vCluster A and move it into vCluster B as demand shifts from A to B, right? That's the kind of really exciting stuff that we're doing with vCluster auto nodes. So definitely very, very advanced feature.
And do it so quick, right? Like that demo right there, literally before we came on here, all I did was Terraform apply to bring up 2 virtual machines on Proxmox, and then I already had like this brand new cluster. Like it's so fast, right? Like, and then if I don't want it, I just destroy and then just delete this and then just create other ones or resize the VMs super fast and then like add those. So it's really cool. Yeah, we got some good
VMs
stuff.
is a good keyword. We do have something in auto nodes as well, in auto nodes, which will go in the direction of automatically creating VMs. You probably can guess there are a couple of projects on the CNCF landscape that deal with creating VMs on Kubernetes. Don't want to spell out exactly the project name, but you can probably guess what it is. We have some really exciting integrations on that end as well for vCluster auto nodes.
All right, we got another question. Is it possible to shift or scale workloads between vClusters? For example, can we compile a model in vCluster v1 and then deploy it to a different vCluster, vCluster 2, with a GPU for inferencing?
Probably you want to take this
one?
one?
I mean, that depends a little bit, I guess, how you ship models, right? In general, like OCI images, you can super easily switch between vCluster 1 to vCluster 2. For storage, basically, we don't really do anything there much. So like if you have like a CSI driver that supports this is also possible. You basically can just create a persistent volume in vCluster 1, right? Compile their model there. And then essentially, if you have the same CSI driver on that other vCluster, import that PV there and then mount it to some other workload, right? That definitely works. Although that's also not a vCluster specific feature, but yeah, that's definitely supported.
So you're saying there's just too many use cases, because you could see a world where you're adding a bare metal machine with a GPU and adding some VMs that maybe have like a portion of a GPU, right? Like, and maybe you're setting up to where you run these smaller things on that portion of a GPU and the larger things on the entire bare metal thing. So like I don't know. I'm already thinking of different things I want to demo and show off. So like I'm kind of excited about it. It's trying to think about things a little bit differently than we're used to. So
yeah,
all right, I'm super excited.
Fabian. We do have something cool coming up as well in terms of vCluster snapshots. A lot of you are probably familiar with that feature right now. It's really great to take a etcd snapshot of your cluster and the entire state. But we are integrating with the CSI drivers now to actually create volume snapshots as well as part of this. And I think that will solve some of these topics around how do I move data from one vCluster to another vCluster, for example, right? Or, roll back or, essentially migrate my vCluster from one host cluster to another one, right? Like all of these kind of scenarios often require, obviously, there's PVCs, right? There's stateful applications in vCluster. So that's one of the bigger workflows that we're working on right now as well. I'm not sure if we have anything about this on the landing page about the 3 big announcements, but somewhere in between, we're going to make an announcement on that topic as well. So that's to come as well.
Awesome. So we'll have some more stuff coming out over the next couple of weeks, and then we have another one coming in September 9th. I've linked to the launch page if you want to find it. I'll also post it on the LinkedIn video for this, since it doesn't automatically add it. But I think do we have anything else we want to add? Or I think that's about it. We kind of teased kind of the stuff that's coming. Hopefully people are kind of excited about that. Hopefully people play with this, give us some feedback, let us know like what they're setting up and what they're configuring, or like, showing us your EKS at home type setup. But we'll see you again soon. Lukas or Fabian, you want to say anything before we head out?
Maybe last comment, you can check out vcluster.cloud if you want to quickly spin up the vCluster platform to test it out. A lot of the features that we're releasing, are behind certain feature flags, etc. But when you, spin up vCluster Cloud, it'll give you a free trial to pretty much all the capabilities of vCluster. So if you want to test out any of these cool features that come out, just head to vCluster Cloud, spin up a vCluster platform instance. When you connect your vCluster to it, it'll automatically give it a license key. So you can pretty much test any kind of feature that you're seeing in our documentation, even if they're labeled as enterprise capabilities. It's a great way to just explore and test things out.
It's a great point, especially with the private node setup now. It's easy for me to add in nodes in there instead of connecting it to a full cluster. All right, awesome. So I guess we'll see everybody next time. Thank you for joining. Leave some comments on the YouTube channel if you want to have us answer some stuff that we didn't answer here today if you're watching it later. But we'll see everybody next time. Thanks so much.
Thank you.
Thanks.